This lesson is about factorizing expressions that involve roots. These roots could be square roots, cube roots, four roots, or a root of any index. Basically, the expression is not a polynomial, and our goal is to factor out the GCF. And as we know, if we have x to the n and x to the m, the GCF is x to the smallest exponent. This applies to expressions that involve roots. Here we have some rules that we're going to refer to throughout the lesson. Let's begin with this example. We are factorizing an expression. This expression is not a polynomial because it involves a square root, and a square root has an exponent that is 1/2, not a positive whole number. So it's not not a polynomial. Our job here is to factor out the GCF and make this a little bit easier to analyze if we have to analyze it in calculus or pre-calculus. Okay, so what we are going to do first is write the expression with roots written as exponents or in exponential forms. As we know, square root of x is the same as x to the 1/2. We have three variable factors, x to the half, x squared. The GCF of those is x to the 1/2, as I have indicated here. It is common to take out a fraction coefficient if a fraction is present in the expression. Now let's talk about factorizing fractions out of an expression. Whenever you factor out a from b, remember that you're dividing b by a. Factorizing is the same as dividing. So if I am factoring out, let's say 1/3 from 5, I am taking 5 and dividing it by 1/3. Okay? And to make this easy, we have a property. As you might know, if you have a whole number divided by a fraction, you can take that whole number and multiply by the denominator of the fraction instead of dividing by the fraction itself. So keep that in mind. So if I'm factoring out a 1/3 from 5, I will be multiplying 5 by 3 to get 15 to see what goes inside the parentheses. Another thing you need to know is that when we are factoring x to the 1/2 from, let's say, x, we have to again take x and divide it by x to the power of 1/2. And for that, there is an exponential property which says that if you have two exponential that you're dividing, you subtract their exponents. So keep these two rules in mind, and let's just go ahead and factorize this expression. Again, we're taking out the fraction 1/3 and x to the lowest exponent, x to the 1/2. So to see what goes here, we are going to take 5 and again multiplied by 3. That gives us 15. So for the coefficient, we are going to write down 15. And x to the 1/2 is already out. So you get 1, which again, you don't have to write down. Next, we're going to factor out 1/3 from 6. You take 6, you multiply it by 3, that gives you 18. So the coefficient for the second term is 18. And when you're taking out x to the 1/2 from x, you take x, you divide it by x to the 1/2. And again, remember, we are just subtracting their exponents. 1 minus 1/2 is equal to 1/2. So for the variable part, we get x to the power of 1/2. That's what happens when you factor x to the 1/2 out of x. You end up with x to the 1/2. Here, 1/3 is already factored out. To factor out x to the 1/2 from x squared, we are dividing x squared by x to the 1/2. You can just subtract their exponent. We have 2 minus 1/2. You can write 2 as 4 divided by 2 because I want to make the denominators the same. Minus 1/2. That gives you 3/2. All right, so we get x to the power of 3/2, and we are done. This is the factorization of our expression. Let's move on to the next example. So again, a non-polynomial. Step 1, we write every root in exponential form. Here we have a 1/2 x, does not involve a root. We have 3 divided by the cube root of x. There should be a property for when the variable part is in the denominator, which I don't have here. But what you can do is reciprocate the cube root of x. Cube root of x is the same as x to the power of 1/3. Okay, bring it to the numerator and make the power negative, as you can see here. And then here we have x squared cube roots. That is x squared to the power of 1/3. You can multiply the powers. That would be x to the 2/3. So cube root of x squared written in exponential form is x to the power of 2/3. This is your step 1. Rewrite everything in exponential form. Now again, we have coefficients, 1/2, 3, and 1/5. Remember, we want to take out the fractions. If you take out 1/2 from 1/5, you're not going to end up with a whole number. Nor if you take out 1/5 from 1/2, you're going to end up with a whole number. So what you want to do is get the lowest common multiple of 2 and 5. The lowest common multiple is the smallest number that is divisible by both 2 and 5. That number would be 10. Okay, so instead we're going to take out 1/10 from this expression. I'm going to put the 1/10 out. And then we have the variable factors. We have x to the negative 1/3, x to the 2/3. The one with the smallest exponent is x to the power of negative 1/3. Okay, so we are now ready to see what should go inside the parentheses. And again, remember that we are dividing every time we are factoring out. All right, so let's see what happens when we factor out a 1/10 from 1/2. We have to take 1/2 and multiply it by 10 instead of dividing it by 1/10. So that would be 1/2 times 10. That gives you a 5. So 5 is the coefficient. And when you're taking out x to the negative 1/3 out of x, remember you are subtracting the exponents. So the power of x is 1. We're going to do here 1 minus negative 1/3, which turns into 1 plus 1/3. Again, you can think of 1 as 3/3 plus 1/3. That gives you 4/3. 3 plus 1, that's 4 out of 3. So the variable part is x to the power of 4/3. Next term, we have a coefficient of 3 and we want to factor out a 1/10. So again, take 3. Instead of dividing by 1/10, you multiply by 10. That gives you 30. So the second coefficient inside the parentheses is 30. And this should be the negative here. Pardon me. Okay, and then we have we have x to the negative 1/3, which is already written out. So we are left with only negative 30 for the second term. All right. And lastly, for the third term, we're going to take 1/5 divided by 1/10. Instead, you take 1/5, you times it by 10. 1/5 of 10 is 2. It's the same as saying 10 divided by 5. So the coefficient here is 2. And once again, we are taking x to the 2/3 divided by x to the negative 1/3. You subtract their coefficients. All right, so that would be 2/3 minus, you subtract the exponents, negative 1/3. That is 2/3 plus 1/3, which gives you 3/3 or 1. You end up with x to the power of 1 or just x. We have the factorization of this expression. Let's look at the next example. So once again, we are going to rewrite the expression in power form. We have 2 cube root of x to the power of 5 is the same as x to the power of 5/3. Remember that the index of the root is always the denominator of the exponent. Plus, now here we have cube root of x inside the denominator of this whole thing. So once again, we are going to bring that and make its exponent negative. That's x to the 1/3 in the denominator. When you bring it up, it becomes x to the negative 1/3. And that goes in front of 2x squared minus 16. So we are almost ready to factor this out. Here we have, if you notice, two groups. I have this group and this group. Within the second group, inside the parentheses, we have 2. And that 2 with 16 have a GCF of 2. So you can start by factoring out that GCF from the second group. I'm going to take the 2 and put it in front of x to the negative 1/3. Inside the parentheses, we are left with x squared minus 4. So here we have our two groups. Let's take out the GCF. Among the coefficients, we have 2, which can be factored out. And among the x's, x to the 5/3 and x to the negative 1/3, we can take out x to the power of negative 1/3. Remember, x with the smaller exponent, and negative 1/3 is obviously the smallest of 5/3 and negative 1/3. All right, and let's carry out the factorization. So I'm going to write out the GCF. You can open parentheses or brackets, it doesn't matter. Here, to see what goes inside the bracket, first of all, the coefficient of 2 is already out. So we are factoring x to the negative 1/3 from x to the 5/3. You again take x to the 5/3 and you divide it by x to the negative 1/3. And again, in that case, we have to subtract their exponents. So 5/3 minus negative 1/3, that will give you 5/3 plus 1/3 or 6/3, which leaves you with 2. So we get x to the power of 2 when we take out x to the negative 1/3 from x to the 5/3. Then we have plus, again, 2 is already out. X to the negative 1/3 is out. So we're just left with x squared plus 4. Now here I don't have to write out the parentheses around x squared plus 4 because this plus does not impact the terms inside the parentheses. If this was a subtraction, the parentheses would be required because we would have to subtract every term. Okay, now you can combine, pardon me, that should be an x minus 4, x squared minus 4. Now we're going to combine what's inside the bracket. 2x to the negative 1/3 out. Inside the bracket, you could turn the bracket into parentheses, it doesn't matter. We have x squared plus x squared, that is 2x squared. And then we have minus 4. All right, so we are not done until the expression is completely factored out. Look at what we have inside the parentheses. We have 2x squared and 4. These coefficients have a GCF of 2 in common. I'm going to take that out. When you take a 2 out of the parentheses, that 2 is a factor that can be multiplied with this 2, and that will give us 4x to the negative 1/3 times x squared minus 2. But we are pretty much done. It is common to return an exponential with a negative exponent back to the denominator. So we can rewrite the final result as 4 times x squared minus 2 divided by x to the negative 1/3 goes into the denominator, and it can be rewritten as the cube root of x. Make sure that the cube root is displaying. So there we have it. This is the final result. And again, the ultimate goal is to rewrite an expression like this in a manner that is analysis ready. You want your expression to be in factored form, so when you're in pre-calculus or calculus, you can analyze the factors and therefore the expression. Let's look at the next example. This looks a little bit scary, but here we have obviously roots, particularly square root of 16 minus x squared. To make this problem less intimidating, I have decided to replace 16 minus x squared with u. And look at the rewritten expression. Okay, so here instead of negative square root 16 minus x squared, we have negative u to the power of 1/2. And here we have x squared over square root of u. And since this square root is in the denominator, I can reciprocate it and write it with a negative power. And inside the denominator, we have 16 minus x squared, which is just u. All right, so this is what we have. It is a lot nicer to look at. Let's take out the GCF from the numerator. We have two terms, negative u to the half, negative x squared u to the negative 1/2. Their DCF is u to the smaller exponent, so u to the negative 1/2 is what we're going to take out. The first term on the top does not have x in it. The only base that is our concern is, in this case, u. So let's write out the factorization. With u to the negative 1/2 out, we open parentheses. We're going to get negative. There's a negative here. I'm just copying it down. So again, you are going to take u to the 1/2 and divide it by u to the negative 1/2. We are subtracting the exponents. 1/2 minus negative 1/2. That's just 1/2 plus half, or 1. So 1 is the power u. You could just write that as u. And then we have minus x squared. U to the negative 1/2 is already out. Close the parentheses. In the bottom, we have u. And once again, if you have a factor with a negative exponent, it is common to put that in the denominator and write it with a positive exponent. So here we get u to the power of 1/2 times u, which is already in the denominator. On the top, we have negative u minus x squared. You can actually take out the negative from the numerator if you want to. And what you want to do next is to multiply these two factors. When we multiply two exponentials, we add their exponents. So we end up with u 1/2 plus exponent 1, that's 3/2. And on the top, I'm going to again take out the negative. We get u minus x squared. And then finally, what you need to do is replace a u with 16 minus x squared. All right, so let's start with the top. And make sure when you take a negative out, you end up with a positive inside the parentheses. With the negative out, we have 16 minus x squared plus x squared. And then in the bottom, u is 16 minus x squared. The whole thing going to the power of 3/2. We can simplify a little further by subtracting those x squares, and the end result is actually negative of 16 over 16 minus x squared to the power of 3/2. I mean, look at what happened. This whole expression reduced to something a lot more simple to look at.